Hey physics kids, this is Mr. Pickett. I wanted to spend some time talking about this last kind of week and make sure that you guys are ready to rock for your application lab. I'll do this occasionally, and sometimes this is just a good opportunity to refresh some of your knowledge. What I have opened up is our first learning cycle, and specifically I've opened up the concept enhancer, the notes. Not that I'm going to go through the notes in here, but I really want to make it clear the things that we've been talking about and learning, and so you guys kind of know what you need to know to successfully complete your application lab. In the concept enhancer, it details through mainly three different pieces of content. It talks about displacement, velocity, and acceleration, but certainly not just the definition of those things, but specifically how to find those values, what those values mean, and how they are incorporated with each other. And so with these three values, we've done a lot of graphing work, and we're learning quite a bit about slope and meaning about slope. And that's really what I wanted to spend some time talking about today. So what I've done is I've opened up a Google Sheet, which we've done this as well. And what I'm going to do is I'm going to make two different columns. I'm going to make a column that is going to be time, and I'm going to make a column that's going to be displacement. And before I add any data into that, I want to make sure that we understand a couple vocab words. So we have learned a little bit about distance, or at least you should know a little bit about distance. Distance mainly means how far something has gone, right? So usually we measure distances in miles or feet or inches, but remember in this class we use the metric system, and so our standard unit of measurement for distance is a meter. But in physics, we like to make things more complicated, but more specifically, we like to make things as specific and as detailed as we possibly can. So instead of using distance, we try to use the term displacement. And displacement has to deal with certainly how far something is in relation to some, I'm going to call it a reference point, but it's basically from here to there. So it's not just about covering a distance, it's saying how far are you from a particular point. So they mean very similar things, but they aren't exactly the same. And so I'm going to put some data in here in terms of time and displacement. And what we're going to say is that the time is going to increase by a second each time, and that our displacement is going to increase basically by 3 seconds each time. So there we go. So I've got this data. I'm going to graph it, and again, part of this tutorial is to help you guys remember how to graph information. So I've got time and I have displacement, and I'm going to go to Insert, I'm going to go to Chart, I'm going to click up here, change the default bar graph to a scatter plot, and I'm going to X out of the editor, and there we go, we've got our very first graph. And what it's showing is that the displacement is continuing to change as the time changes, which is awesome. And so a couple things that I know about slope, and I'm gonna make sure I write down slope. Slope means, well, specifically it means rise divided by run. We've gone through a lot of in-depth stuff talking about change in the y divided by the change in the x. But what we're trying to do is we're trying to understand that slope has particular meanings for the types of graphs that we're looking at. And what we're looking at is the displacement versus time graph. And what we know is that the slope here, if we look at the rise value is displacement and the run value is time. And so I know that there's this awesome equation for velocity that is change in displacement divided by change in time. And what we're going to know is that there's an eerie similarity between slope and velocity. Again, slope is rise divided by run, and velocity is my change in my displacement divided by my change in time. And here's the main connection for this specific graph. For graphs that are displacement versus time, your slope is your velocity. It's an awesome thing. So what do we know about slope? Well, I know the slope can be calculated here. I know that the slope of this line from here all the way up appears to be straight or linear, which means that it's not changing, and I know that the slope is positive. And if I know all those things about the slope value, then I also know that those same things about velocity. So again, I know that the slope for this graph is positive. I know it's constant or linear, and I also know what the value is. It looks like that it goes up 3 and over 1, so the slope value is actually 3. And so if the slope value is positive, it's constant, and it's 3, that means that my velocity is positive, constant, and also has a value of 3, specifically 3 meters per second. Sweet, awesome. So we know a little bit about velocity. Now I can change this graph pretty significantly if I double everything. So I go from 3 to 6, then from 6 to 12, 12 to 24, and 24 to 48. And what we notice is this graph changes and the slope changes. It looks like the slope increases, or the steepness of my line increases as well. And if the steepness of my line increases or my slope is increasing, that must mean that my velocity is increasing. Again, I'm talking about slope here. So I'm talking about what does this line look like? Or what's its angle look like? And this angle is pretty severe compared to this angle right here. And so as my slope is constantly increasing or teetering towards the y direction, that means my velocity is doing the same thing. I can change this as well. I'm hopefully going to start up here. 4, 12, 6, 3, and 0. And what we notice is that the slope of this line is negative. The value of slope is actually going down as well. And so that means that your velocity is negative and your slope is decreasing. So there's a lot of fun things that we can learn about this. I can also show a slope that doesn't change. Okay, so we have a slope that is non-existent, and that means that I don't have any velocity, which makes sense. If I'm literally not changing my position or my distance away from the starting point, that probably means that I'm not moving and I have no velocity. Okay, so if I come back, that's displacement right there. Okay, for the most part, that's what displacement is about. And what we find is that now we have other terms that we've talked about. We've talked about velocity, right? We've talked about what the equation is for it. It's change in displacement divided by change in time. But what does that look like maybe on a graph or on data? How do I exactly calculate that? Well, what I do is I take my change in time and I make also a change in displacement column. And Google Sheets is really, really neat. I can put functions in here by starting with equals, and then I can take a cell and I could subtract another cell from this. And what this means is that between these two time points, how much time has elapsed? And that's a pretty obvious answer. Just 1. Okay, 1 second's always in between each one of these time points. And my displacement is going to be really easy to calculate because there's no change whatsoever. And if I want to calculate my velocity, well, I'm going to take change in displacement divided by my change in time, and I get no velocity, which is what we just talked about right here. There's no slope and there's no velocity. But if I rechange my displacement values, and again I go up kind of how it initially gone, what we notice is that my velocity is now constant because my slope is constant. Okay, well, let's double everything. All right, so my slope is increasing, and so my velocity is increasing as well. Okay, let's try something different that we haven't really seen yet. No, that's not what I want to do. Let's do here. Let's do 64, 76. Let's do 2. Let's do 81. Okay, so this is an interesting one here as well. What I notice is that my displacement value is going up, But if I look at my slope starts off really high, or otherwise I have high velocity, and then my velocity is actually decreasing. Yes, my displacement is getting higher, but what's happening is I'm moving away from my starting point, but I'm doing it more slowly. And that makes sense. Again, my velocity starts out really significantly high, and then it slowly goes down. So there's velocity, but I can also graph velocity versus time. I can do that. And those graphs are going to look different than these other graphs are. But I really just wanted to spend some time making sure that the students understood a little bit more about slope, a little bit how to use the graphing software in here, and also a little bit more about velocity. Acceleration is something that we have referenced a little bit. I will write the definition down for it. Acceleration is equal to my change in velocity divided by my change in time. So acceleration has the same relationship with velocity that velocity has with displacement. And we'll cover that more specifically in our next couple learning cycles, but I wanted to spend some time talking to you guys about that. Enjoy the rest of your break, and I'll see you guys on Tuesday.